Okay, so this is a problem number 3. Now this question is also once more is about weak base, and this is actually for us to calculate equilibrium constant for base, and they give you the pH of this solution and what is the value for Kb for this base known as what is known as just a B. Okay, so this is a kind of the opposite problem. Before the Kb was given and they want you to calculate pH. Now this time they give you a final pH, and so that we can back calculate what is the Kb value for this kind of the base. And so the first off, the understanding the what is given here. Okay, so this is a molar concentration of weak base. Okay, so this, let's just call this as a B as a base, and this is what is known as, we can understand that this is a initial concentration. Okay, represent as a B, it's already right there, and they give you a pH, which means we can calculate H3O plus concentration, which is a 10 to the minus pH, that concentration. So, but what is actually tricky, a little bit tricky thing about it here is understanding that we actually wants to know OH minus. That makes our calculation easy, which is 10 to the minus POH, and that is, and from the pH, and the POH is 14. So we can calculate POH. Using that POH, we can eventually calculate OH minus. So let's write the equation first to understand what we are dealing with here. So we have a base, weak base, and H2O dissolve in water, and they will form equilibrium with a H plus, because base take H plus from the water as a proton acceptor, and then they generate OH minus. That's what the weak base do, and then the equilibrium constant is Kb. Okay, so what is my ICE? And this is the one. And so we need to calculate the POH value from the side. Okay, so POH is 14 minus 11.57. That is a 2.43. So therefore, OH minus concentration at equilibrium, which is 10 to the minus 2.43. Okay, so that will give me, okay, so let's just give me a little bit separation on what we're dealing with here. Okay, and so that will give me the 0.0037 molar concentration of OH minus once more, right? Okay, so we got this value. Yeah. Okay, so in the beginning, the concentration was 0.199 molar. And then on the equilibrium condition, the pH value is such and such. We can calculate OH minus concentration following this relationship. And so therefore, OH minus concentration is 0.0037. Okay. So this is all the information, and then we can just figure out the rest of the puzzle by filling up this equation. So which is, it's pretty reasonable to assume that small amount will be dissociated or accepting the proton to be the conjugated acid, which is an X plus X. So therefore, the value of X is 0.37. That's pretty for sure. So that this value is 0.199 minus 0.0037. 0.0037, which is a small number. So you have either options of approximate this value to be 0.199, as you can do, or you can just simply calculate this. So I don't want to use this approximation because I don't need an approximation. It's very simple to calculate those values. So therefore, I'm going to just go ahead and calculate Kb, which is defined as base concentration, conjugate acid concentration, and OH minus concentration. That is 0.199 minus 0.0037, 0.0037 to the square. Okay, so that's the concentration. So if you calculate that, the Kb value is 7.0, 10 to the minus 5. Okay. Okay, thank you for your attention.